up watching baseball with my dad. And to this day, I love everything about it. The crack of the bat, the roar of the crowd, the energy. Who would believe one little baseball has so much energy? But how does an object like a baseball have energy? What is energy, and what is the law of conservation of energy? Our universe is made up of a combination of energy and matter, or substance. But what exactly is energy? Scientists define energy as the ability to do work. Energy is what makes matter move or change. Energy is all around us and takes all sorts of forms. It takes energy to run around the bases, to throw the ball, to turn on the lights in the stadium, and to cook the food that feeds the fans. It even takes energy for the fans to digest those delicious ballpark hot dogs. In physics, the standard measure of the amount of energy something has is the joule, which is abbreviated as the letter J. There are other measures for energy that are sometimes used throughout the world. Calories and kilowatt hours are other energy measurements that are probably familiar to you. The interesting thing about energy is that it cannot be created. It can't be destroyed either. Energy can only be converted or transferred from one form to another. This idea is known as the law of conservation of energy. A look around a ballpark tells us that there are many different forms of energy in our world. But all of these types of energy can be put into one of two categories. They are either potential energy or kinetic energy. We will learn more about potential and kinetic energy in just a minute. First, let's review what we have learned about energy. Question 1. What is energy? A. Sound combined with motion. B. The ability to do work. C. Atoms and molecules. D. None of the above. The correct answer is B. Energy is the ability to do work. Question 2. What is the standard measurement for energy? A. Yard. B. Milliliter. C. Joule. D. Gram. If you answered C, you know that the joule is the standard measurement for energy. Question 3. Potential energy is one type of energy. What is the other main type of energy? A. Applied energy. B. Calculated energy. C. Kinetic energy. D. None of the above. The correct answer is C. Potential energy and kinetic energy are the two main types of energy. What is potential energy? Most forms of energy fall into one of two categories: potential energy or kinetic energy. Potential energy is the stored energy, or the energy of position. There are several types of potential energy. One type is chemical energy. This is the energy that is stored within the chemical bonds of an object's atoms and molecules. Batteries, petroleum, natural gas, and coal are examples of chemical potential energy. Food is also considered chemical potential energy. When you eat that hot dog and popcorn at the baseball game, they are loaded with energy that could be used by your body. Think of chemical potential energy as fuel. Another type of potential energy is mechanical potential energy. This energy is sometimes called elastic potential energy. It is potential energy that is due to the compression or expansion of an object. This energy is stored in the object's tension. The energy in this stretched elastic band is a great example of mechanical potential energy. A third type of potential energy is gravitational potential energy. This is potential energy that is stored in an object's height or position. Anything that is up high has gravitational potential energy. That pop fly that is caught by a fan way up in the stadium has potential energy because it is now in the fan's hands way above the field. A bike at the top of a steep street or that huge boulder at the top of a hill also have gravitational potential energy. The higher the object is and the heavier it is, the more gravitational potential energy it stores. If the fan accidentally drops that pop fly, or that bike or boulder begins to move, their potential energy is converted to motion or kinetic energy. But more on that in a minute. Let's review what we have learned about potential energy. Question 1. What is potential energy? A. Stored energy. B. The energy of position. C. The movement of atoms. D. A and B. If you answered D, you know that potential energy is stored energy and the energy of position. Here's question 2. Which of the following is an example of chemical potential energy? A. Coal. B. Natural gas. C. Food. D. All of the above. The correct answer is D. All of these have chemical potential energy. Question 3. A bike at the top of a steep hill is an example of what type of potential energy? A. Gravitational. B. Mechanical. C. Chemical. D. None of the above. The correct answer is A. A bike at the top of a steep hill is an example of gravitational potential energy. What is kinetic energy? Let's go back to our bike that is ready to roll at the top of a steep hill. When it is stationary, that bike has potential energy. The second it starts rolling, that potential energy becomes kinetic energy. That's because all moving things have kinetic energy. In fact, the word kinetic comes from the Greek word kinesis, which means movement or motion. So, kinetic energy is the energy an object has due to its motion or movement. The amazing thing about kinetic energy is that tiny things like atoms can have it, and so can massive things like planets. Kinetic energy is related to the mass of an object and how fast it moves. The heavier an object is, or the faster it moves, the more kinetic energy it has. Here's an example. If you have a baseball and a bowling ball on top of a table, both have gravitational potential energy. The baseball is light while the bowling ball is heavier. If each one begins to roll, now they have kinetic energy. If each one rolls off the same table at the same height, which one will have more kinetic energy? Well, an object's kinetic energy is related to its mass. So, the bowling ball. That's because it is bigger and heavier and therefore has more kinetic energy than the baseball. In fact, if you double an object's mass, you double its kinetic energy. Kinetic energy is also known as motion energy. Simply, it is the energy that is stored in the movement of objects. When our star baseball player swings his bat, it stores energy. An object's speed also affects its kinetic energy. So the faster he swings, the more energy is stored. If you double the speed on an object, its kinetic energy increases by 4 times. In our batter's case, that energy is released when the bat hits or collides with the ball and slows down. Kinetic energy can be transferred from one thing to another through collision. In this case, that energy is transferred from the bat to the ball, so it flies far out into center field. I told you baseball was filled with energy. Let's review what we just learned about kinetic energy. Question 1. The word kinetic comes from the Greek word kinesis, which means what? A. Height. B. Speed. C. Motion. D. Timing. The correct answer is C. Kinesis means motion. Here's question 2. When is an object's kinetic energy released? A. When it speeds up. B. When it begins to move. C. When it slows down. D. All of the above. The correct answer is C. An object's kinetic energy is released when it slows down. Question 3. What affects an object's kinetic energy? A, its mass. B, its speed. C, its location. D, A and B. If you answered D, you know that an object's mass and speed affect its kinetic energy. What are the different types of kinetic energy? Our ballpark is full of kinetic energy. One type of kinetic energy is electrical energy, which is electricity moving through an object. Matter is made up of atoms. These atoms contain tiny particles called electrons, which are constantly moving. The movement of electrons in an object depends on how much energy it has. We have learned how to force electrons in an object along a path from one place to another by using special materials that can carry electrical or electron energy. These energy-carrying materials are called conductors. Materials that do not carry electrical energy well are called insulators. So, electrical energy is transferred by moving electrons from one atom to another. That giant scoreboard at the ball field lights up using this type of energy. When the scoreboard is wired into the electrical panel and the power is turned on, the transfer of electrons results in the electricity needed to light it up. Have you ever felt the warm glow of the sun on your face at a ball game? Well, that's an example of another type of kinetic energy, known as radiant or light energy. Radiant energy is electromagnetic energy that travels through space in electromagnetic waves. Sunshine is a great example of the power of radiant energy. The powerful energy from the sun's rays provides the fuel and warmth that make life on Earth possible. Remember we said that all matter is made up of molecules? Did you know that these molecules constantly move or vibrate? If an object is heated up and its temperature rises, its molecules move faster and collide with one another. Thermal energy is what we call the energy that comes from the temperature of matter. The hotter the substance, the more its molecules vibrate, and the higher its thermal energy. If you go to a baseball game early in the season, you might reach for a steaming cup of hot chocolate to warm up. Your hot chocolate has thermal energy from its vibrating particles. If you pour in some milk, some of the heat from your hot chocolate is suddenly or spontaneously transferred to the cold milk particles. Your cup of hot chocolate becomes cooler because its thermal energy was transferred to the milk. The amount of energy transfer needed to change the temperature of matter depends on the type of matter, its size, and its environment. Let's say you want to boil 2 pots of water. One is large and the other is small. It will take longer for the larger pot to boil because it contains more matter, water, and it will require more thermal energy to reach boiling temperature. Once the boiling pots are removed from heat, the smaller pot will cool down quicker because it has less thermal energy. You may have created thermal energy without even knowing it. Remember that chilly day last winter? When you rubbed your hands together, you created friction that created heat energy. Let's review what we have learned. Question 1. What do we call materials that can carry electrical energy? A. Insulators. B. Contractors. C. Compressors. D. Conductors. If you answered D, you know that conductors carry electrical energy. Question 2. Sunshine is an example of what type of kinetic energy? A. Radiant. B. Electrical. C. Thermal. D. None of the above. The correct answer is A. Sunshine is radiant energy. Question 3. What happens to molecules as they heat up? A. They stop moving. B. They fall apart. C. They move faster. D. They disappear. The correct answer is C. Molecules move faster when they heat up. What is work and what are energy transfers? We learned earlier that energy is not created or destroyed. It just changes from one form to another. This is the law of conservation of energy. We also learned that energy is the ability to do work. But what is work? Work is done on an object when energy is transferred to that object. Energy is also transferred from one object to another when a reaction takes place. Energy comes in many forms and can be transferred from one object to another in the form of heat, light, motion, or any other form of energy. When two objects interact, each one exerts a force on the other that can cause energy to be transferred to or from the objects. Remember our swinging baseball bat? Work was done as energy was transferred from the player's body to the bat, and then again when energy was transferred from the bat to the ball. And remember our digital scoreboard? Work was done as electric energy was transferred from the electrical panel to the scoreboard. And what about those hot dogs? Those tasty hot dog buns were warmed by a toaster that was plugged into an electrical socket. Electrical energy was transferred to the toaster, which then transferred thermal energy to the hot dog buns through its heating coils. And when you use motion energy to chew that hot dog and bun, you help to transfer its energy to chemical energy that your body can use as fuel. See? No wonder baseball is my favorite sport. A baseball game is so full of energy. The crack of the bat, the roar of the crowd, and the energy of baseball. Let's review what we just learned. Question 1. What is work? A. When energy is transferred to an object. B. The movement of atoms and molecules. C. When an object moves rapidly. D. None of the above. If you answered A, you know that work is energy transferred to an object. Question 2. What types of energy can be transferred from one object to another? A. Heat. B. Light. C. Motion. D. All of the above. The correct answer is D. Heat, light, and motion can be transferred. Here's question 3. When a toaster heats up, electrical energy is transferred to what type of energy? A. Motion energy. B. Electromagnetic energy. C. Thermal energy. D. Potential energy. The correct answer is C. In a toaster, electrical energy is transferred to thermal energy. Thinking question. What are the benefits and drawbacks of some of the common energy sources used in the United States?